is your last homework assignment for this review section. We're going to review transformations. That is what we were just doing before school was closed, so this will be familiar to you. I'm actually just going to do a couple problems from the homework with you, but before I do that, I want to review a couple things, and you might want to write this down. Or just keep this video up on this page to help you remember all of these things. There's three types of transformations, or transformations. There's translations, and when you see that, you're going to be given some ordered pair, and it's going to tell you to change it to x plus or minus some number, y plus or minus some number. This number tells you how far right or left to move it, right if it's positive, left if it's negative. This will tell you how far up or down, up if it's positive, down if it's negative. So that's translations, and then you'll literally just take a shape and translate it right and down, or whatever amount however amount it says. Reflection is where we take a shape and we flip it. So sometimes you'll be asked to flip it over the x-axis or the y-axis. So let's say you have like this shape. You want to flip it over the y-axis, it gets moved over here. Or if you want to flip it over the x-axis, it gets moved up there. It's just a mirror image flipped over. Sometimes though, you'll be asked to reflect it over a line such as like x equals 3 or x equals some number. When you have that, you're going to draw a line that's straight up and down through that number. So for example, with this x equals 3, I'm going to draw my x and y axis. X equals 3 is right here, so I'm going to draw a line straight up and down. And then I can take some shape, let's say we have this shape right here, and reflect it. So I want it to look the same, but backwards, as we reflected over that. We can also have a line reflected over something like y equals -2. That is going to be a flat line. So we would have something like this. Here's my x and y axis. Here's the shape I want to reflect. And it's going to reflect over y equals -2, so that needs to be a flat line through -2. And when I reflect that, it just gets flipped upside down over that line. It needs to be the same distance away below as it was above. Okay, so that's reflections, and then rotations. And this is the one that took more work, but we were getting the hang of it. With rotations, you take an ordered pair, and if you're asked to rotate it 90 degrees clockwise or 270 counterclockwise, you take the original ordered pair and you flip the two of them. So you flip the x and the y, and the x value changes signs. So if it was positive here, it becomes negative here. If it was negative, then it becomes positive. If you're asked to flip it upside down, do the 180, or rotate it upside down, do the 180, you just change the signs on both of them. So if they're negative, make them positive. If they're positive, make them negative. And if you're asked to flip or rotate 90 degrees counterclockwise, 270 clockwise, you switch the ordered pair, and the y becomes negative. So we're going to take that and do a couple problems from the Big Ideas homework. So open that up, and let's start number 1 together. Okay, if you don't have it open yet, pause this video. And we're going to do number 1 together, just to make sure we know how to use this technology. What's expected here. So number 1 says graph triangle XYZ with vertices at 2, 3, -3, 2, and -4, -3. And its image after the translation xy becomes x, y plus 2. So our first step is going to be to graph those 3 ordered pairs. So 2, 3, and then the next ordered pair Oh, that is not the right point. Wow, how do I do it? Oh, I can just drag it over. So right 2, up 3. I don't know why I put that point there first. Second point is left 3, up 2. And it magically draws a line for us. And then the third point is -4, -3. So I'm going to go left 4, down 3. And that, again, connects for us. To connect it back to the starting point, I just am going to touch that starting point and it draws the triangle. We are then asked to translate it left and right 0, up 2. So I'm going to now take each point and just move up 2. And then connect it back. Okay, so number 2 is like that. Number 3, graph the polygon over the x equals 4. So remember, you're going to be reflecting it. So we'll graph the original image and then reflect it over the line x equals 4, which is this line right there. That goes straight up and down. That line that I just showed is not your answer. That's the line you'll be reflecting it over. So it's just this one that's all the way up and down there. Similar here, y equals 3 is this flat line. So this is what you'll reflect it over. So that's number 4. Number 5 is another translation, but then once you translate, you also have to reflect it over the y-axis. So that one has 2 steps. This one wants us to rotate 90 degrees about the origin. So I do want to do this one with you. Because when it says 90 degrees, it doesn't specify clockwise or counterclockwise. It is counterclockwise if not specified. So we're going to take our original ordered pairs and 90 counterclockwise. We can look back. What we said was 90 degrees counterclockwise, the ordered pair becomes this. So we're going to take it, x, y, and switch it to this, -y, x. That will become, let's see, this first order pair, we switch the 2, the y value becomes positive as it changes because it was negative. Switch the 2, the y value changes sign, so it's -2, 2. Switch the 2, this number, -3 becomes positive, so it's 3, 3. And then you'll plot the 2 points, or sorry, the 2 sets of points, so you get your 2 separate shapes. So I won't do the plotting with you. You have to do that on your own. And then, oh, my ordered pairs are not good. Let's do this. That's okay. So your rest just should be, let's see, there's a 180, and then I think there's a 270. Oh, no, there's number 8. I forgot about this one. Okay, let's talk about this one as well. Let me get rid of this writing. Okay, number 8 says determine whether the figure has rotational symmetry. So can you turn the shape and make it land on top of itself so it looks the same? And it does. I can take this point and rotate it to right here, and the shape will look the exact same. So we just need to figure out how many degrees you have to rotate it. So we can take this shape and split it from the center into 5 sections. Those sections are triangles. One circle is 360 degrees. So what we're doing is we're taking that one circle of 360 degrees and cutting it into 5 equal sections. 360 divided by 5 is 72. That tells us that one single rotation is 72 degrees. We want to describe all rotations that will get it back on itself. So it looks like 72, and then 72 plus 72 is 144. and so on. It just lists the two of them, but this is the correct option, because that's the one that lists the two of the correct rotations. And then this last one, oh, actually it's not the last one. Number 9, describe congruence transformation to get from one shape to the next. So you'll have to figure out how to get from one to the next. Let's see, 2 to negative 2, 3. Yeah. I'm going to have you guys try that one on your own. If you need help, reach out to me. That's a pretty good problem there. And number 10. Oh, this one. We talked about this one. We decided that the angle of rotation to get from this shape to this shape with just rotating it is just 67 times 2. So again, number 9, I want you to try it on your own because I don't want to do it for you because I think that's a pretty good problem. But I will help you if you ask me. So if you're super confused and you've tried the help me with this problem button, just send me an email or message me on Canvas and I'll help you.